Welcome to another deep dive, everyone. Today we're going really big. We're talking about cosmic inflation.
Wow, yeah, cosmic inflation. So have you ever wondered how the universe went from something so small, unbelievably small,
Like smaller than an atom even.
way small, yeah, to this giant expanse that we see today?
Yeah, it boggles the mind.
It really does.
And get this all happened in less than a blink of an eye. We're talking less time than it takes light to cross an atom. It's crazy fast.
It really is. We're talking about the very first moments of the universe, so early on that a nanosecond seems like forever compared to
I
this.
can't even imagine.
It's hard, but that's what makes this period so important. It helps us try to figure out these big mysteries about the universe, like why does space look the same in every direction?
Okay, so we have this crazy fast expansion, something super tiny becoming universe-sized. But how can anything even go faster than the speed of light? Doesn't that break all the laws of physics?
Yeah, you'd think so, right? But here's the thing. It's not that things are moving through space faster than light. It's space itself that's getting bigger, kind of like it's stretching, like a giant rubber band.
Okay, I'm trying to picture this.
So imagine you draw some dots on a balloon.
Okay.
And then you blow it up. The dots aren't moving on the balloon,
Sure.
They're just getting further apart because the balloon itself is expanding.
Okay, I'm with you. So it's the space between objects that's growing faster than light, but the objects themselves aren't actually breaking any speed limits. That's a pretty sneaky loophole.
Yeah, the universe finds a way.
So why is cosmic inflation so important?
Yeah.
What would the universe even look like if this hadn't happened?
Well, without inflation, the universe would be totally different and honestly pretty boring. Just picture this vast empty space with a few particles here and there.
That does sound boring.
Really spread out, no real structure or anything. No galaxies, no stars, no planets.
So no us.
Yeah,
Oh.
definitely no us.
So cosmic inflation is like the ultimate real estate developer. It takes this little tiny patch of universe and turns it into this huge place filled with stars and galaxies.
I like that analogy, yeah. Inflation basically smoothed everything out in the early universe, and it spread the energy and matter around evenly. And that's what gave us the seeds for the big structures that we see today.
Okay, I can see that. Without it, we wouldn't have all these galaxies clustered together.
Exactly.
So cosmic inflation is the reason why we have all this cool stuff to look at and study.
Yeah.
But what even caused it? What force could make the universe inflate like that?
That is the million-dollar question. And the one that keeps cosmologists awake at night. One of the main theories we have is that there was this mysterious field. It's called the inflaton field, and it's what did it.
The inflaton field. Sounds kind of sci-fi to me.
It kind of is. It's like the cosmic fuel that made the universe grow so fast.
Okay, so how does this inflaton field even work?
Well, imagine this. You have a ball rolling down a hill. At the top, it's got all this potential energy. And then as it rolls down, that energy turns into kinetic energy.
The energy of motion?
Right. So think of the inflaton field, like that ball. And the universe is the hill. As this field kind of rolls down, it loses energy. And that energy release is what makes the universe expand like crazy.
Okay, I'm following you. The inflaton field was this super powerful energy source that kickstarted the universe's biggest growth spurt. But here's a thought. If the Big Bang was this massive explosion of energy and matter, doesn't that mean it wasn't actually the beginning?
Bingo. That's exactly it. The Big Bang wasn't the start of everything. It was more like a chapter in a much bigger story. So the inflaton field's energy, eventually it turned into those particles and radiation that we always hear about with the Big Bang.
Right.
That created this super hot, dense soup that our universe came from.
Wow, so the Big Bang was actually the aftermath of this inflation period. That's pretty wild. It makes you think about how much we still don't know. But wait, if cosmic inflation was so powerful, is it still going on somewhere else?
No, that's where things get really interesting. The idea of inflation leads to this mind-blowing possibility. Maybe our universe isn't the only one.
Wait, hold on. Are you talking about the multiverse?
Yeah.
Multiple universes?
Exactly. What if inflation happened more than once? What if it happened countless times? That leads to the idea of eternal inflation. New universes are constantly being created, kind of like branching off from old ones. You end up with this vast multiverse, a whole bunch of universes.
Whoa, okay, that's a lot to take in. So you're saying there could be tons of other universes out there, each one with its own laws of physics and stuff.
It's a crazy concept, right? It's mind-bending, but it actually makes sense if you think about how cosmic inflation works.
Okay, definitely need a minute to process all this. We've gone from a tiny speck to a universe-sized explosion, and now to the possibility of infinite universes. We'll dive deeper into this in just a bit.
Yeah.
All right. My brain is still trying to wrap itself around this whole multiverse idea. But before we get too lost in what-ifs, let's get back to our own universe for a bit.
Yeah, that sounds good. It's easy to get carried away thinking about all those possibilities with cosmic inflation. But what's really cool is that this theory, it's not just some crazy idea. There's actually some good evidence to back it up.
Right. I was reading about this thing called the cosmic microwave background radiation.
This CMB.
Yeah, CMB. How does that fit into all of this?
So the CMB, it's basically like the afterglow from the Big Bang, a snapshot of the universe from way back, like 380,000 years after the Big Bang. It's like looking at a baby picture of the universe.
Oh, baby pictures. Okay, so what does this baby picture tell us?
It shows us some pretty incredible things. Like CMB is super uniform. The temperature is almost exactly the same everywhere we look.
Wait, so the early universe was like this perfectly heated oven with the same temperature everywhere. Wouldn't you expect some like hot spots and cold spots after the Big Bang? It was a pretty chaotic event.
You would think so, right? And that's where inflation comes in. Inflation makes this uniformity make sense. Imagine this really tiny part of the universe, right? Super hot, super dense. Now inflate that at an insane speed.
Okay, what happens?
Well, the heat and density, they get spread out evenly across this huge expanding space. It's like taking a drop of ink and putting it into a giant ocean.
Ah, okay. So inflation basically smoothed out the early universe.
Yeah.
Created this uniform temperature that we see in the CMB.
Exactly. But there's even more. The CMB also shows these really subtle temperature variations, little tiny differences.
Yeah.
They're actually the seeds of the giant structures we see in the universe today. Galaxies, clusters of galaxies, everything.
So those tiny temperature differences, they're like the blueprints for the universe we see around us.
Yeah, kind of like that. And if we didn't have that period of super fast expansion, those little fluctuations wouldn't have been stretched out like they were, and we wouldn't have those huge cosmic structures that we see.
Okay, so inflation really does tie everything together.
Yeah.
The uniformity of the universe, the structures, even the seeds of those structures. But what happened to the inflation field after all that? Did it just disappear?
Well, remember that analogy with the ball rolling down a hill?
Yeah.
Eventually, that ball reaches the bottom and stops, right? So the inflation field, it didn't just vanish. It eventually reached a stable state. Its energy kind of decayed, and it turned into all those particles and radiation that filled the early universe.
So the inflated field's energy got recycled, transformed into the building blocks of, well, everything.
Yeah.
Stars, planets, us, everything.
Precisely. Protons, neutrons, electrons, photons, all those tiny particles that make up everything around us. It all came from the inflated field's energy.
That's amazing. It's like this direct connection to the very beginning of the universe. You mentioned the inflated field reaching a stable state. So does that mean inflation is over? Or could it still be happening, maybe somewhere else, creating all those other universes we were talking about?
That's the question, isn't it? And it brings us back to that idea of eternal inflation. Some theories say that even though inflation might have stopped in our part of the universe, it could still be going on in other regions, creating new bubble universes all the time.
So it's like this never-ending cosmic fireworks show with new universes popping up all over the place.
It's a pretty amazing image, right? It's a really speculative idea, but it's one of the fascinating things that comes out of how we understand cosmic inflation.
It really is. We've talked about so much today, from the evidence for cosmic inflation to the possibility of a multiverse. But I think it's time to bring this back to us. What do these discoveries about the early universe tell us about ourselves, about our place in the universe?
That's a deep question, you know, and I think it's something that everyone needs to think about for themselves.
It's a big question, for sure. We're talking about events that happened billions of years ago on a scale that's, well, hard to even imagine. How can we relate that to our everyday lives?
Well, I think it's about perspective. You learn about cosmic inflation, the Big Bang, the sheer size of the universe, and it makes all those little things we worry about every day seem, well, small.
I get that. It's
Yeah.
like when you're standing on top of a mountain and you see this vast landscape all around you. It makes you feel tiny, but also connected to everything.
Yeah, exactly. We're not just separate beings on this little planet. We're part of this incredible story of the universe, a story that started billions of years ago with this burst of energy.
And we're made of the same stuff as stars. Those atoms in our bodies, they were made inside ancient stars. It's like we carry a little bit of the cosmos inside us.
It's true. Every element that's heavier than hydrogen or helium, it was made inside stars. And when those stars exploded, they scattered those elements everywhere. And that's how new stars and planets formed, and eventually, life.
So we're not just watching the cosmos. We're part of it. We're literally made of stardust.
It's a beautiful thought, isn't it? And it shows how everything in the universe is connected. From the smallest particle to the largest galaxy, it's all part of this big cosmic web.
Okay, I have to ask. We've explored this amazing journey from a tiny speck to a universe full of galaxies, stars, planets, and even life. What's next? What are the big questions that cosmologists are trying to answer now? What mysteries are we still trying to unravel?
Oh, there are so many. We still don't really understand dark matter or dark energy, and they make up most of the universe. We're trying to find gravitational waves from the very beginning of the universe, right after the Big Bang. That would tell us even more about inflation. And we're always coming up with new telescopes and instruments so we can see deeper into space and uncover new secrets.
Wow, it sounds like there's so much more out there to explore and discover. I can't wait to see what we find out next about our universe and maybe even about ourselves.
Me too. It's a really exciting time to be a cosmologist and just a curious person in general.
Absolutely. Well, I think it's time to wrap up this deep dive into cosmic inflation. Thank you for joining us on this journey through the earliest moments of the universe.
It was great exploring these amazing ideas with you.
And to all our listeners out there, keep looking up at the stars, keep asking questions, and never lose that feeling of wonder at this incredible universe we call home. It is a big question for sure. We're talking about like events that happened billions of years ago on a scale that's almost impossible to even grasp. So how do we even begin to connect that to, our everyday lives?
Well, for me, it's all about perspective. When you learn about cosmic inflation, the Big Bang, and just how incredibly vast the universe is, it makes our everyday worries seem, well, pretty insignificant.
Yeah, I can see that. Like it's almost humbling in a way.
It really is. It's like
Right.
we're not just these isolated beings living on this tiny little planet. We're a part of this massive, incredible cosmic story, a story that started, billions of years ago with this unimaginable burst of energy, and it's been unfolding ever since.
And to think, we're made of the same stuff as stars. I remember reading that the atoms in our bodies were actually created inside ancient stars. It's amazing. It's like we have a little piece of the cosmos inside each of us.
That's actually true. Every element that's heavier than hydrogen and helium, they were all created inside stars through nuclear fusion. And when those stars exploded as supernovae, they scattered those elements throughout the universe. And that's what led to the formation of new stars, planets, and eventually even life itself.
So we're not just observing the cosmos, we're like active participants. We are literally made of stardust.
It's a beautiful thought, isn't it? It just goes to show how interconnected everything in the universe is. From the smallest subatomic particle to the biggest galaxy, we're all part of this grand cosmic web.
Okay, I have to ask, we've gone on this journey from a tiny speck to a universe full of galaxies, stars, planets, and life. What's next? What are the big questions in cosmology now? What mysteries are we still trying to figure out?
Oh, there are so many questions still. Like, we still don't fully understand dark matter and dark energy. And those things make up most of the universe. We're looking for gravitational waves, those ripples in space-time from right after the Big Bang. They could tell us even more about cosmic inflation. And scientists are always building new telescopes and instruments to try and see further into space and hopefully uncover new secrets.
Wow, that's incredible. It sounds like there's still so much to explore and discover out there. I'm excited to see what the future holds for cosmology and what new amazing things we'll learn about our universe and maybe even about ourselves.
Me too. It's a very exciting time to be a cosmologist. Or just a curious person.
Well, on that note of cosmic wonder and endless curiosity, I think it's time to wrap up our deep dive into cosmic inflation. Thanks for joining us as we explore the universe's first moments.
It's been my pleasure.
And to everyone listening, keep looking up at the stars, keep asking those big questions, and never lose your sense of awe at this incredible universe we call home.